Hi, my name is David Hui and I'm a design engineer for Pickering Interfaces. Today, we're going to talk about cross-point matrices and how they are used in functional test applications. There are many commercial off-the-shelf switch products designed to connect automatic test equipment to one or more devices under test. The most versatile of these is a cross-point matrix because it can connect multiple instruments to multiple devices under test simultaneously and without restrictions. In its most basic form, a cross-point matrix comprises independent columns X and rows Y, which may be individually interconnected via programmable switches fitted at each intersection, or cross-points. The most common terminology to describe a matrix size is X columns by Y rows. For example, a 32 by 8 matrix switch module, such as Pickering 40-520 like this one here, has 32 columns and 8 rows. A flexible switch can be made by connecting the matrix rows to ATE instruments and the columns to the device under test. A voltage source can be connected to any two terminals of the device under test, as shown, and a programmable resistor is connected between another two terminals. Operation of the device under test can be verified by connecting a voltmeter between yet another two terminals. The device pin connections can easily be reprogrammed, so this system will serve as a generic test system to test a variety of parts. When pairs of connections are always made at the same time, as in the previous example, a two-pole matrix can be used. Here, two-pole relays are used at each pair of matrix crosspoints, and both signals are switched by a single software command. Although it is easy to visualize a matrix with instrumentation and device under test connections on separate axes, this is not always the most efficient way of doing things, especially when a large number of instruments are required. If each instrument has a dedicated matrix row, and only one or two instruments are used at the same time, there are a large number of relays standing idle throughout the test procedure. These relays cost money and should be employed as much as possible. A more efficient way is to connect instrumentation and the device under test to the matrix columns, and then share the rows for all the required interconnections. There are two main advantages to this approach. Firstly, you very likely require fewer rows, and so the matrix cost will be reduced. And secondly, each interconnection requires two relays to be operated, and so there is less chance of potentially damaging connections being made. A cross-point matrix is usually limited to low-frequency operation due to the long internal row and column interconnections, or stubs. This limits the usable bandwidth because of additional capacitance and transmission line effects. For example, with path Y1 to X1 closed, shown in the green path, a stub, shown in red, appears on the line, which limits the matrix bandwidth. A large system may require more rows and/or columns than a single matrix module can provide. A matrix can be expanded by joining the rows and/or columns of several modules. For example, here, the number of columns have been expanded by using two Pickering 40-520 modules to make a 64 by 8 matrix. 3 modules will make a 96 by 8 matrix, and so on. This configuration requires several external interconnecting cables to be used, thereby increasing cost and negatively impacting signal integrity. Also, the individual matrix modules must be programmed independently. Pickering brick architecture simplified this matrix expansion by providing a backplane, like this one here, which is used to interconnect the rows of individual matrix daughter cards, like this one here. Additional daughter cards may be used to expand the matrix columns. Each daughter card has isolation relays which disconnect it from the backplane when its X connections are not being used. This reduces stub lengths and increases the overall matrix bandwidth. Another advantage of the brick is that it is programmed as a single large matrix, greatly simplifying the software management task. In some cases, both matrix rows and columns need to be expanded. For example, a 128 by 128 matrix can be configured using 4 of our LXI 64 by 64 modules, as shown. That concludes this video on switching matrices. I hope that you have gained valuable knowledge for your test system design. To learn more, contact your local Pickering salesperson or go to pickeringtests.com. Thank you.